Hello everyone, in this video we are going to discuss about differentiation when we have a combination of vectors. So let's start and write the topic over here. So what we are going to understand is what we do when we have a combination of vectors. So what can be a kind of combination that you can think of in your mind? It may be addition of vector something like f plus g, or maybe subtraction of vector something like f minus g. So in that case, suppose you have to find the differentiation with respect to x of some function f and g like this. So we can find them separately, like df upon dx plus dg upon dx. Both of them would be equal. In the similar way, we can also do this if the sign over here is of subtraction. Now next you have to find the differentiation of cf, where c is some constant, in this particular case. What you have to do is that you have to take out this c, take out the scalar, and find the derivative of this function, something like this. This will give you an answer. Now we will move further, and next we will understand a case where we have been given two functions which are multiplied with each other, like f into g. What do we do in this case is that we take out f and take the differentiation of g with respect to x, and then add it by taking out g and taking the differentiation of f with respect to x. I hope that it's clear to you. Now we can do same thing when there are two functions like this, f upon g. But one thing that you must keep in mind, that g should not be equal to 0, otherwise this would become undefined. Now if we have to do this, in that case what we do is that we take out this f, we take the differentiation of g with respect to x, and we subtract taking out g and taking out differentiation of f with respect to x, and we divide this entire numerator by g square. I hope it's clear to you. Now I will give you a problem to do. Suppose this is a problem in which f is given to you as 3x square plus 2x plus 1, and g is given to you as 2x plus 4. Now what you have to do is that apply all these four formula that I have told you, and check that whether they are correct or not. So you have to apply all the four formula, and you have to check whether these formulas are correct or not. Definitely they are correct, but you have to check it by yourself. Now there are some names given to these formula. This particular formula is often referred to as product rule, and this is referred to as quotient rule. I hope it's very clear to you why we refer to this one as product rule and this one as quotient rule, because in this case we are taking the product, and in this case we are taking the quotient. Now let's move on to product rules in the case of gradients, in the case of curl, and in the case of divergence. So let's start. So we will give a new heading over here in which we will be talking about product rules in the case of curl, gradient, and divergence. Okay, so we are going to understand now product rules. What we are going to understand is product rules. Okay, now the very first rule, we will start up with gradient over here. So let's write here gradient. Okay, now what we do in case of gradient, suppose you have to find the gradient of f into g. If you have to find the gradient in this case, what you simply do is take out f, gradient of g, plus take out g and gradient of f. I hope it's clear to you till now. Now we will move on to the next formula. which if you have to take the gradient of A dot B vector, what we do, A cross curl of B plus B cross curl of A plus A into gradient, A dot gradient plus B vector dot gradient, and we multiply this entire thing by A vector. Here it would also be B vector. Again, if you want, you can try this by putting the values of f and g, which I have given you in the earlier question, and for A vector and B vector I will give you some values, so put them to check whether this formula is correct or not. For A vector you may try something like 3x square I cap plus 3yz j cap plus 4z square k cap. And for B vector you can keep something like 4xy I cap plus 3y square j cap plus 9z cube k cap. So try to prove both of these, or try to check whether both of these formula are correct or not for these two vectors. So you have to check out the second formula for this vector, and the first formula you will check from the example that I gave you earlier. Now let's move on in the case of divergence. We have understood about the formulas in case of gradient. Now we have two more formulas for the case of divergence. So let's write it over here. Divergence. So in case of divergence, the very first formula is something like this: f a vector, and this would be equal to f divergence of A vector plus A vector dot gradient of f. And the second formula, this was the first formula in the case of divergence, and the second formula in case of divergence would be divergence of A cross B vector will be equal to B vector dot curl of A vector minus A vector dot curl of B vector. Why I am saying this curl, I hope you understand. You have seen the last video in the series in which we talked about curl, gradient and divergence. Now similarly we have formulas for curl as well. So let's see the formula which is for curl of vector. So in case of curl of vector, the formulas that we have are as follows. The very first formula is curl of f a vector. What we do is take out f, curl of a vector minus a vector cross gradient of f. Similarly we have one more formula in which we take out curl of a cross b vector, and in this case what we do is we take the gradient of b vector, the divergence of b vector, and we take the divergence of a vector, multiply it with b vector, and we subtract b vector along with a vector. I hope it's clear to you. Now let's move on to three quotient formula. We have seen the formula in the case of curl, in case of divergence and in case of gradient. Now we have three formulas for quotients. So let's write over here quotient formulas. Okay, now let's see what are these quotient formulas. The very first is gradient of f upon g. This would be equal to g gradient f minus f gradient g divided by g square. This complete thing would be divided by g square. Now the second formula for quotient is this. Minus a vector dot gradient of g. Okay. Don't think it as some circle. This is an inverted triangle which stands for gradient. I'm writing a bit fast, so sometimes this can happen. Please keep this in your mind. Now, taking the curl of a vector upon g. So in this case, what we do is we multiply g with curl of a and add the cross multiplication of a vector with the gradient of g, and we divide this entire thing by g square. So all these formulas are very similar in nature. What you have to do is that at least you have to keep them in your mind. I'm not saying you to remember them completely. You can just write it on some paper and the work can be done, but please prove these formulas, or at least see if these formulas actually work by putting the values of f, g, a vector, b vector and the various values that I have given you. If you try it that way, it would be very helpful for you in the coming videos. For this video, this was all. In the next video, we will continue with second derivative, and we may also start integral calculus. Thank you very much for watching.